Hello and welcome to the third of my PICAXE programming videos. In this video we're going to cover variables, for next loops and analog sensors. So we'll start off with just a label named main, and I'm going to introduce you to something new called variables. Now variables are just numbers which can change, they vary, that's why they're called variables. And in PICAXE these are B0, B1, B2, etc. Now one of the things you can use variables for is to create a loop which will loop around a certain number of times and then carry on. This is called a for next loop. So you structure this command by saying, for example, main, and then you put for b0 or b1 or b2 equals 1 to 10, and then you put whatever you want it to repeat 10 times. So let's say high 1, low 1, pause 500, and at the bottom you put next b2. Now what this means is for the values of b2, which are between 1 and 10, so it starts setting b2 at 1. It'll go through this program. When it reaches next, it'll go back to this for and add 1 to it. So if it starts off at 1, when it reaches next, it makes it 2 and starts again. When it reaches next, it makes it 3 and starts again, all the way to 10. When b2 gets to 10, it ignores the next command and just carries on. So for example, put end. It should on off, and it will repeat this through 10 times, with the value of these two getting greater every time. There you go. This is sometimes written as symbol from the last video, counter equals b0, and instead of for b2 or b0, you just put counter. And all that's doing is renaming it. I mean, you can put at the top symbol counter and use for counter 1 to 10, next counter, if you prefer, or you can use the variables themselves. It's up to you. So there's a b0, b1, b2. But you've got to keep the variable you're using the same throughout. So you can't have for b0 and then next b1. They've got to be the same one. So for example, both b1 or both b2 or both b0, etc. The next thing I'm going to show you is something called analog sensors. If I open up a tab in Google Chrome, I'm going to show you the difference between analog and digital sensors and inputs. Let's see if I can find a good image on Google Images. Okay. Now the difference here is that analog can take any value along this curve. So it can be here or here or here, anywhere along the curve there. So it can take any value. A digital input can only take two values, which are 1 and 0, and that's it. And that's shown here by the square waves. So keeping that in mind, if you remember from the last video, input 0 or input 1, etc. can only be 0 or 1. For analog sensors, can be any value in PICAXE from 0 to 255. And you read an analog sensor through one of three channels. If you click on simulate here, you'll see that on the simulation we have A0, A1 and A2 at the bottom. Now we can change these to whatever we want, and those are the analog values. So whereas a digital input here can be either on or off, this can be partly on all the way from 0 to 255. Now the command for this is read ADC, which is just saying read an analog sensor. The channel you want, so for example, if we were reading A0, then we put read ADC 0, if we're reading A1, we put read ADC1, and then we put the variable we want to read it into. So what that does is it takes whatever the value of the analog sensor is at the time and changes a variable, so B0, B1 or B2, to that value. And then we can use the if commands and the greater than, less than or equal to symbols to get the program to do what you want. So let's say we've got a dark sensor, or a light that comes on once it gets too dark. So if our light sensor is analog sensor 0, then we can read that value into B0 and then say if B0 is greater than or less than or equal to, I'm going to put less than 50, or in fact greater than 50 just because, then high 3 and there. Now here it will keep looping round, keep taking the value of A0. At the moment it's not greater than 50, but as we increase it, see right now it's equal to, but it's not greater than. If we increase it, then output 3 comes on, because it's asked it to do that. I'll give you another example. So let's say, for example, we have any sensor at all. I mean, the one in the exams are usually light sensors. So read ADC1. In the exam it will say which inputs the analog sensor's on. So read ADC1, let's use B3. This time, if it's above a certain value, so let's say it's a temperature sensor, and if it's too hot, one light comes on, and if it's too cold, a different light comes on. So let's say if B3 is greater than 20, then pin 0 will come on, but if B3 is less than, let's say, 10, then high 2. And another thing to remember is when using analog sensors and if commands, you've got to have the reverse if you want it to come off. Because at the moment we're asking it to come on if it's above a certain amount, but not to go off. So let's say if B3 is less than 20, then low 0. And if B3 is greater than 10, then low 2. I'll just separate these out for you. Now you're probably a bit confused at the moment, but I'll just run the simulation and show you what all this means. So at the moment, the value of channel 1, read ADC1, is less than 10 because it's 0. So one warning light comes on. If we increase it to say 15, then that light will go off, and it'll stay off, and no new lights will come on. It's at the it's at the right temperature. It's not too high or too low. It's not above 20, and it's not below 10. If the temperature goes up on our sensor, a different warning light will come on, because we've got an if command and a greater than, and of course if we were to run it through again and lower it back to normal, that light would go off. Analog sensors can be quite tricky, so if I were you, I'd practice using read ADC and then the channel and then a variable, and practice if commands with equals, greater than and less than to get the hang of them, because you're probably a bit confused just watching me go through this and simulating it. So do really practice. I think I'm running out of time, so in the next video I'm going to go over a few examples of past papers. See you then.